Hi everyone, we're the Algorithmics, and this is Sightsee USA. It's an interactive road trip planner that simplifies trip planning with optimized routing and immersive visuals. We built this to eliminate the overwhelm of choosing stops, calculating distances, and manually mapping routes. Let's dive in. The objective of this project is to design an optimized travel route for summer sightseeing destinations within the United States. By leveraging real-world data such as user ratings and visitor reviews, the project aims to help travelers discover the most popular and picturesque locations in a smart, efficient manner. The model enables users to select the number of places to visit and a starting point, then generates the optimal sequence of stops to minimize total travel distance and time. Key features of this project include an interactive map displaying the complete travel route, filtering options to customize trips by state, popularity, and number of destinations, and a clear trip summary showing total distance, estimated driving time, and a number of stops for better trip planning. The project is divided into 3 main stages: data collection and preparation, route optimization, and data visualization. The initial stage involved importing essential libraries and loading a large dataset from Kaggle containing 3,124 tourist destination records across the USA. Since latitude and longitude data were missing, critical for route calculation, these geographic coordinates were obtained through the Google Maps API and appended to the dataset. Comprehensive cleaning and validation steps were performed, including converting all column names to Snakecase for consistency, removing columns and rows with missing values, dropping duplicate addresses to ensure unique locations, confirming all entries are from the USA, verifying latitude and longitude values fall within a valid geographic bounds, and ensuring that all US states are represented in the dataset. These preparations guaranteed a clean, accurate, and comprehensive dataset ready for route modeling and optimization. The second stage was to develop an efficient sightseeing road trip route covering a selected number of top-rated tourist spots, visiting each location once while minimizing total travel distance. The process began by creating a baseline model that randomly ordered the destinations. The total distance and estimated driving time of this random route were compared to establish a performance benchmark. To improve upon this, an optimization strategy was applied using the nearest neighbor algorithm, which iterates through the top N locations and selects the closest unvisited location to the current point. This efficiently constructs a route, minimizing overall travel distance. Key highlights include the selection of the top 9 tourist destinations in Florida based on a weighted score, a custom metric combining location ratings and review counts. This balances quality and popularity, ensuring trustworthy rankings. The baseline random route resulted in a travel distance of 248.73 kilometers and an estimated driving time of 3.11 hours. The optimized route reduced the distance to 136.17 kilometers and a driving time to 1.7 hours, nearly a 45% improvement. The nearest neighbor algorithm ran swiftly, producing results in just 0.02 seconds, demonstrating the feasibility of fast, effective route optimization. In the final stage, the project focused on visually optimized routes using interactive maps. By plotting points, users can intuitively grasp the improvements in travel efficiency and route compactness offered by the optimization. Finally, we visualized it all with an interactive map, so users can clearly see the improvements in route efficiency. Some key architectural decisions were using React Context for clean separation between a theme, route, and map. We used MapLibre and MapTiler for customizable mapping, Framer Motion for smooth modal animations, and we fetched location images using the Wikipedia API. Some places either have no relevant image or a totally unrelated one. In those cases, we fall back to the placeholder image using placehold.co API. This is the modal inform mode, where users select a state, number of stops, and starting point. It's managed by our route context, which handles all the form state cleanly. Once the form is filled, the user clicks Generate Route. That triggers data loading, filtering, ranking, routing, and image enrichment. In here you can see it live, where we select California, 9 stops, pick a starting location, and then generate. When the form is submitted, we enter preview mode. The modal updates with the stop's image, name, address, the stop count, and the total distance and estimated driving time. The driving time uses 60 miles per hour as a baseline. And on the map, markers pop up for each location. A line animates between them, and we fly to the first stop to start. As you can see, after clicking Generate Route, we zoom into the first stop and our modal shows an image, name, address, the stop count, and then the total distance and estimated driving time at the bottom. You can also see the current stop details update as we cycle between the locations using the buttons at the top of the modal. And then to reset, click Generate New Route. It resets everything to form mode. We built a custom theme toggle using CSS variables and a global theme context. When switched, everything updates, including the map style, and we redraw layers and markers. And here's the theme toggling in action. We also made the design responsive, fit for any screen size above 320 pixels. In here, we show a full reset and rerun of the program. To recap, Sightsee USA empowers users to quickly plan and experience road trips using optimized routing, visual map interactivity, and theme-aware UI. We've built a fully modular, scalable tool with clean code, strong UX, and thoughtful technical design. Thank you for watching.